problem. So I'm going to give you this problem. Hold on. Undo. Okay, if we look at this problem now, okay, we look at this problem. No, I mean, I'm not going to do it yet, but I'm just going to explain. If you look at our structure over here, right? When we analyze our structure, what will we use? Will we use tension, compression, or shear? And what is even more not confusing is what will we use ultimate tensile or ultimate or use strength? Which one will you use? Okay, so from textbook, right? If you go back to textbook, okay, if you look at the textbook, okay, so if we go to textbook, so probably you guys have seen this in 2P. So if I go to the textbook, let me find the textbook. Okay, so if we go to the textbook now, so there's a page where they calculate factor of safety. I hope I can find it. I should have done this earlier. Okay, here it is. So if you look at the textbook, right? I'm going to copy from the textbook. Okay. So from the textbook, we can see that the factor of safety is equal to the ultimate strength divided by the what? By the allowable stress. Okay. So any opinion? So where ultimate strength is this is ultimate strength. Okay. Now, any comment with this formula? Anyone? Is using the ultimate strength correct or wrong? Or when to use the ultimate strength, when to use the use strength? Anyone, please. Hello? Lajinder. Any idea when to use the ultimate and when to use the yield? Or always use the ultimate?
I'm not sure.
Yeah, I'm not sure. I like the answer. How about Bebek?
I guess if you're looking at it as an absolute, then using the ultimate stress is fine because it is the absolute max that you're using. But if you want to be safer, I guess you would use the yield strength.
Bebek, you are going to become a very good lawyer, okay? Okay. So this is what a textbook is, okay? The textbook say you saw me got this formula, okay? So I'll specify this, okay? The textbook is not wrong, okay? But what if I tell you, okay, like what Bebek say, if I want to be more conservative, I'll use strength, right? Bebek, right? So generally, okay, if you are working with a brittle material, right, your factor of safety will be equal to ultimate divided by allowable stresses. Okay. However, when you're working with ductile material, all right, the factor of safety is equal to U divided by allowable. Anyone will tell me why, please? Why is it in ductile material, right? You use the yield, whereas brittle, you use the ultimate. Anyone, please? Why is that the case? Right? You don't get this from the textbook. The textbook say, okay, ultimate strength, ultimate strength. Okay. But any idea, anyone know why? Okay, so if I have no answer, so that's where that's where an engineer has to be aware of. Okay, so let me draw your trend. So this is the trend for brittle material. Okay, so this is for brittle. Now let me. So this is for brittle. Okay, and the next one is for ductile. Okay, so this is for ductile. So for brittle material, right, you have 2 points. So the ultimate strength for brittle material and the ultimate strength, not ultimate, the yield for brittle. So what you realize is the ultimate strength for brittle material is very similar to the yield of brittle material, right? So for brittle material, it does not really matter at all whether you use yield or ultimate. Whereas for ductile material, so this is my yield for ductile material, and this is for my yield for my ultimate, sorry. All right. So what you realize that the stress ultimate for ductile material is what? It's so much more greater than the yield for ductile material. Okay. So you can see down here, right? The yield is 250. In tension, let's focus on tension. The ultimate is what? 400. Okay. Sometimes it's not so much, sometimes it's much more. Okay. So if it's a ductile material, but what do I mean by ductile? Like steel, aluminum, titanium. Okay. Okay. Use the use strength. If you have brittle material like concrete, okay, glass, for example, carbon fiber is pretty brittle. Okay. Then you use the what? You can use the ultimate strength. Are we clear? Okay. So don't always take the textbook as the true value. Okay. You need to know when to use what. Okay. Now, let me go further. Now, if you look at our structure on the left-hand side, it is neither loaded in is under combined loading. It's 3D loading, right? Right, it's 3D loading, and what you see is you have normal stress, you have a torque, you have shear forces. Whereas in a test where or from the materials handbook, like what you see in this table over here, the tests are carried out in either just tension. When I say just tension, they just do tension. Just compression, okay? Just in torque, shearing stress. They don't have, but they cannot do tests like how your structure is loaded. Okay. So all these stresses over here, right? All these stresses over here are all unidirectional. Okay, all these are all unidirectional. So I'll write this one for you. These are all your principal stress. So these are all your principal stress. Okay, this one is also your principal stress. Okay, so one is the principal stress in the ultimate strength. The other one is your principal stress in yield strength. So I'm going to define out here in your principal stress. right? Shear stress is equal to what? 0. Okay, your shearing stress is equal to what? 0, which is true. If you look at over here under tension, the shearing stress is equal to what? 0. In compression, your shearing stress is also equal to 0. And what is reported for your shear, right? Shear, these are known as your tau max. Okay, these are known as your maximum shearing stress. So just to recap, for ductile material, you use the yield strength. For brittle material, you can use your yield or the ultimate, okay, because the values are pretty close. And what you see those values in terms of tension or compression are all your principal stresses. Means zero shear stress is added on it, okay? But unfortunately, if you see your structure down here, it has both what? You can see it can be under tension or compression, okay? And it has what? Shear. So if we are going to sketch out element K, okay? So we are going to sketch element K. So element K is over here, right? So we're going to sketch out the stress field, or we're going to sketch the stresses acting, okay, acting on element K. Okay, so this is just a sketch. Okay, so we are going to sketch this in 2D. So we are going to look in the X and Y direction. Okay, so if this is just an example, okay, I'm not saying it's doing this or this is that. So the structure can be under, if I look at it, I'm just going, it can have tension over here, right? You can have shear. Okay, in some circumstances, you have compression. Okay, so this is your stress, how the stress are acting on element K. Okay, now if I were to draw the elements on the tension, okay, if I draw the element, it is just in tension. If I draw the element for compression, under compression stress, it will just be compression. And if I draw the element during testing, it's just shear. Now, question for you guys. The three elements I've just drawn and element K, are they under the same loading condition? Yes or no? Anyone? Are they under the same loading condition? Lux, are you okay? Are you there?
Yeah, I'm
Yeah,
there.
so it's element K and the element that I draw on the right hand side with the tension, compression, and shear, do they have the same loading condition?
Maybe, yeah.
No, the
Like
answer
it's
is
similar.
no, is no. Why? Because on all this is only unidirectional. Yes or no?
Yeah.
Yeah,
Yeah.
it's not the same like element K, right? Element K has compression, have shear. Yes or no? Right? So it's not the same. Then how are we going to use this data? These data are taken from where? Uniaxial directional test, right? One direction. Okay. Now we under this loading condition, okay, we have a 3D loading condition. You have stress X, you have stress Y, you have shear shear X intersecting plate in the Y direction. You have three different components. Whereas down here you have one. So now the question is, how are you going to use this data? Hey, listen. This is where the value of this course comes in.